These are in listen-only mode.
Good evening, everyone. I hope everybody can hear me. Welcome to yet another thought-provoking webinar session. I'm Menaka. Some of you know me. For the new attendees, let me take you through the process once again. I'm Menaka, and I work with the School of Data Science at the Institute of Product Leadership. So, to give you a short brief on product leadership, we started in the year 2012, and we are into executive education, training, and corporate coaching. We have made our mark in the space of product leadership, product marketing, data science, and other emerging technologies. To know a little bit more about our institute, there is nothing better than people who have seen success through us, right? To hear from the horse's mouth is always better. So my colleague will share our alumni success stories in the chat window. Please have a look. We have 1,800 plus alumni across 220 MNCs. Have been quite lucky to have worked with companies like Microsoft, VMware, etc. We are tied up with various very well-known universities. We have different executive programs on product leadership, science, agile, and other emerging technologies. To know more about us, if you are in Pune, please attend this session. It's a products and data science career session. It's an info session which will give you an opportunity to interact with the senior founders of the institute and the faculty. And there would be a lot of conversations on how to ride over the mid-career crisis, which way to go, what are the new technologies that are to be picked up, not to be missed, etc. My colleague will share the registration link on the chat window. Please have a look. Okay. So we have a very, very interesting speaker today with us. I'm very, very happy to introduce Mr. Nikola Sucevic. He's the Chief Data Scientist in Smartfren Telecom. He's put up in Indonesia right now. He's from Sweden. And I must say, just before this webinar started, I was just having a conversation with him, and this is going to be a very fascinating session, I'm very sure. So, what is happening in the telecom industry. So from the time when smoke signals and drums, were used for communication, maybe in the African continent, we have come a long way. Telecommunications as a concept has developed exponentially. Now, if we speak about India, all of you know that with Reliance Jio, a new chapter in telecom was born. And leading it was none other than Mr. Nikola Sucevic. At present, Nikola heads the data analytics practice in Indonesia and Smartfren Telecom. He has filed a number of patents and publications on data analysis, networking, and geolocation. In 2017, he won the much coveted Data Scientist of the Year award at the Big Data and Analytics Summit. We are very honored to have you with us, Mr. Nikola. Welcome to this session, everybody. I hand it over to Mr. Nikola.
Okay, thank you, Menaka. I hope I'm audible. Good evening, everybody. I'm really pleased to have the opportunity to share some experiences from data science, how I have seen it for the last maybe 15, 20 years, especially last 4 or 5 years. And maybe the most interesting would be the part that I can share about data science experience in Geo and growing the company from 0 to more than 200 million users. And I've gathered a couple of slides just to get on my thoughts into some structure, but really it's up to you. If you want to ask questions, maybe half an hour I can talk about what I have experienced, and then we can go on to questions if there is any questions. I will try to share now the, let me see, I'll try to share the slides. Is that, are they visible now? I guess.
Maybe it's just taking a second. Have you accepted?
Okay.
The presentation there? Yes, done.
Yes. Okay. So basically, I quickly just going through my background, just to mention that I've been studying mathematics and physics, and did postgraduates on electronics, but specializing in data acquisition systems. But that was in the mid of 90s. And really the data in that time was more connected to collecting the data from the optical devices and from the electronics devices. There was not that much data circulating around the world, and there were no interconnected databases, but statistics and data analytics principles were more or less the same as today. The way how the physicists or theoretical physicists in that time were analyzing or modeling the data, the principles were the same. Mathematics and algebra is very similar. So I think that getting into telecom was just life circumstances. I've got a job in Ireland, in Ericsson, R&D in that time, in the end of 90s, and basically became a data analyst for telecom, in telecom R&D. It's mostly performance management, KPIs, analytics. So my domain is a telecom, and I'm probably a telecom engineer as the one of the career paths that has worked with data in telecoms, and for last 20 years I've seen different situations, and data science was not always a mainstream data analytics approach. So apart from data science and data analytics, there is a huge area in telecom that is connected to algorithms, and algorithms are regarded as a base for the telecom equipment, and they use a lot of statistical approach. So I did spend quite a lot of time working on geolocation algorithms and any kind of GIS algorithms, and had some experience also in teaching. After university and my postgraduates, I've been teaching on electronics as a teaching assistant, and later, since I've been in telecom after I've been in telecom for 8 years, I went to Ericsson Academy and was teaching telecom for 1 year as a course. It was not really a university course, but more like an industry course of optimization of the network and analyzing the data for the network. So I feel that kind of experience of interacting with the telecom guys and engineers that come from different backgrounds helped me a lot to learn how to listen for especially what are the people problems and how to solve them, and gave me also some confidence to call myself a telecom engineer, even though I'm coming from mathematics and experimental and theoretical physics. So nowadays I really go as a telecom engineer and have no does not feel handicapped compared to somebody who was just doing the telecom. So domain is something that can really be acquired at work, and I would encourage everybody to, apart from the developing data science skills, to choose the domain and develop in one direction, because it's very helpful in communicating with people that you are trying to help using data science algorithms. So now I wrote here, it's being part of some startups early, and let's say even hacker in that time in 90s, and it was the time when we were able to change the code of the software. We were able to decompile, compile, and everything. All this kind of work increases the curiosity and increase the confidence. Even though it's not very structured, I would encourage everybody to try to understand how actually a computer works, and not breaks into any systems. Of course, that's not advice, but try to get familiar with the technology, not only from the interface point of view, but from understanding bits and pieces of the electronics behind. So my message here is that you can actually, from all the people that I've worked with, we don't really care where they are coming from or what is their goal, as long as they know, as they can do it now. So usually the ideal way of working with somebody is just demo the idea. If you are a programmer, you can just demo, and we can just keep on building on top of that demo. Or in other case, when there is very hard to demo, then we can talk, okay, maybe let's see what is your background and what is the probability that you and your team will be able to deliver something like that, or what is your future plans, and how will you fit into all of this. So this is about that background. It's maybe not classical way to becoming a telecom engineer or the data scientist, but it's one of the possible ways. I'm not particularly specialized as a programmer, though I program in a couple of languages, but I don't see myself as a designer, not even as a system engineer, even though I tried and understood quite a lot about telecom system design and worked at places and the labs for designing 3G and 4G network. But all of this is really irrelevant as long as you know how to do something that you want to do. And then you go straight to demoing and showing to people how things are working. So why data science? Okay, these slides are a little bit. Why data science? There is a, I don't know, slides are a little bit stretched, so I don't know if you can see the full slide. Let's see. So basically, why the data science is in telecom, and why do we use it so much today? It's the first thing is like philosophical. Statistical minds generally are not carried away with what they see. So we don't go with a specific case and make a conclusion based on what is happening on one example. And one number does not mean everything. So data science is helping us to see the bigger picture. A lot of times, just data directly looking at data is a little bit blinding and paralyzing the making decision and moving forward. So machine learning is helping to remove the fear in the decision making, because it can give you some ranges and confidence intervals for making the decision, and it's just smoothing the way of decision making, not only for yourself but for anybody that you are trying to help to make a decision. So from that point, any models that you are building, it's not only it's not a recommendation system or the pure automation system, it's a decision support system. So it's very important to enable people to make a decision so they can move forward, so the industry can move forward. And the third thing is that was drawing me toward the data science is that you would like to have a helping friend that can actually model it in the way that is like expert, giving advices, and generally it's not playing the games. Just a moment. Sorry, I'm trying to move the slides, but they're a bit overstretched. Or
Nikola, I think that's okay. We can see the content in the slide, so it's okay.
you can see the whole slide.
Yes,
because
yes.
I cannot see it's
Okay.
half.
No, you can continue. Okay. No problem.
Okay. So on the other side, there is a practical thing about data science. Sometimes the solutions from data science are the only solutions for the problems that you actually have. So let me try to, so I can see the slides. Okay, sorry for this interruption. I'm just opening slides on another device. So practical reasons for why data science, it can free up your time. You can automate quite a lot of things, and it enables you to think visually. And telecom itself became very complicated. So after 2G, 3G, 4G solutions, 5G, it was almost impossible to learn and run the network the way that you learn all the parameters and all the technology deeply, and learn all the engineering. So if you really want to run very complex network, you need simplified and data science scientific approach toward the analyzing parameters, looking for the connections between the decision making and the systems. It was the only way to involve the data science and make things much more simpler. So data scientists in telecom, we went through a couple of phases. Actually, I would say maybe I personally went through a couple of phases. So I will look from my perspective. I would say from 1997 to 2005 was working in different parts of the world for the telecom industry, and I can just remember trying to use the association rules when we first deployed the 3G networks in Italy. I was as a machine learning enthusiast in that time. Was sitting in my office and supporting Ericsson with the meetings with the customers, and coming out with the parameters that are most probably causing the disasters that are happening in some sites. And since the number of parameters was huge and they had very strange names, and you couldn't have one person being expert for every parameter, I could say that this parameter, based on some machine learning techniques, is the reason for a specific problem. But people were not used into something like that. They would say, how it's possible that you don't know exactly how this parameter works, and you actually are saying that this parameter is causing the problem. And even though it was right that there was a lot of people that just didn't understand that, that there is some kind of ways where you don't have to understand 100% of the system to see that there is association rule between this couple of parameters and the outcome. And the other problem was also people were very skeptic about troubleshooting when you isolate the problem without actually looking and analyzing one specific case. So even though it sounds strange nowadays, but in that time, even though statistics was used, the general statistics or the general extraction of the parameters and characteristics of the system were not, that approach was not really popular in telecom. You should be expert for the specific problem, and then when you find out that problem, then you kind of create a story around the problem, and then everybody's trying to fix that specific problem. But the thing is that without data science, it was almost impossible to fix problems that were diverse, and systems became very complex. So many times they would say, you are not 100% sure, and we are a serious company. We don't want to do things if you are not 100% sure. And this is the part where we were still going through the system engineers that learn the system are now trying to transform them into statistical way of thinking that their machine is something that can be unpredictable or predictable into some levels of accuracy of the model that you build on top of the machine. So they didn't really like us. They are coming with all these conclusions that were usually right, and we were coming very fast with them, and the management was usually happy about it. But normal engineers that were experts and they knew exactly what this name of the parameter mean, they didn't like that somebody is just poking their nose in everybody's business. So data science was not encouraged in that time. It was more like a witchcraft business. Then I would say that in phase 2, at least for me, it was between 2005 and 2013. I was working in mostly in US and UK in some quite advanced technologies, algorithm development companies that grown from the startups to very big companies, and working on very interesting algorithms for that had the data science. There was a lot of confidence intervals calculations. We even use this L1 minimization, minimum volume embedding, and so on. so all these things were looking very nice. They would smooth out the maps. We used some convex optimization algorithms. They looked very nice, but they were not marketable because really there were no experts for algorithms in that time with a very good background from the good universities that would say, okay, this is innovation. And on the other side, data science algorithms, they are mostly open source. There is no secrets, and real algorithms. Still in that time was thought that really a really important algorithm in telecom, it should be secret. So that didn't fit into the structure. Only with the uptake of the big data and open source came phase 3, when we basically had I think it's between 2013 and maybe even now, even though geo is a specific case, I can talk a bit more about it. There was the times of the extremes, and many data scientists that worked in my teams, either they wanted to do a lot of hello world applications for data science because they're just learning, like same like me and everybody, but everything has to be machine learning, everything has to be a new cool algorithm. Or there was system design people that really didn't get the way how the data science works and how the innovation works. They would say, and I must say that I heard this couple of times even in India, where they say that we just lock ourselves in the room and we don't go out until we come up with something. And that's the way that I kind of try to change that. You actually cannot limit the time for somebody to solve the problem. You cannot say you have to solve it in 24 hours, or you have 8 hours and then you don't go home and don't work on it. The problem is problem, and people think and work on the problems as long as they don't solve it. And this is a big difference. And usually this kind of projects where people would lock themselves and try to come up with any algorithm, they would end up with massive confusion. And I would say that these kind of leaders were our best customers and clients, because they would always see the scientific approach or statistical approach as a miracle. And I think that would be the same in the future. I think there is some people that just will never get it, how does probability works. And even though they might be very good experts and maybe even understand mathematics, but there is a lot about intuition and the way of thinking about numbers that you have to train yourself for a while, not to come directly in the conclusion looking at a couple of numbers. And in phase 4, I think this is the phase where there is a kind of awakening and realizing that it's a well-established industry, maybe a little bit overhyped, and I think also there is a bit of arrogance that people see in data scientists nowadays. So it's really about making yourself useful, providing the solutions to actual business users, and learning more how to listen, so you can always deliver insights that are actionable and that people can act on top of it. I wouldn't say that that there is a lot of the discussions of what type of tools we should use, what programming languages. After a while, you will be able to use any language if it's necessary for the specific project. And probably you're going to develop quite a lot of libraries that that you only have, and you might share with your team, but generally won't be available as something that you can download from the internet, and this is normal. But and there will be a lot of tools that are coming in. A lot of them have a commercial or commercial goal, like trying to get you to use specific system on the cloud, so you become dependent of them. Some of them are promising that you don't have to program at all, that you can just drag and drop. I think these kind of discussions are more or less irrelevant as long as you are able to quickly adapt any programming languages. I worked since I'm a bit older. Java was my main programming language, and then R and Python. But I think any kind of system nowadays it can be utilized for data science. MATLAB is also a very interesting language for a telecom. A lot of people will say, okay, it's maybe what can I do in MATLAB that I cannot do in Python or in even R? The thing is that there is so much source code written in telecom for Python, especially for the modeling in MATLAB, that sometimes it's not about language, but it's about how do you do it quick enough, and how do you stitch the things together so it comes out in the measurable time. So I think these are three phases, and the phase at the moment is very stable for data scientists. My experience, I can give some short reflection on the geo experience. Well, Geo, it's a telecom company. It was a telecom company. Nowadays it's a data company. It generally didn't have that many people that were doing data science. Even though there was a lot of experts in the area jointly working on the project. Some of them were sitting in the US. Some of them were here in Georgia. Is a huge company that has a lot of parallel projects that and it invests quite a lot in the different ideas. But it was a telecom company with no ambition to create something that will completely change the way how the things are run in telecom. And then just before launching the network, we actually realized that if we just go and apply the regular way without making some adjustments and simplification, it won't be even possible, because India is so huge and there is so much data coming that physically will not be possible to coordinate everything in the old way of running the company and running the data. So that's, in that time, we created a couple of features that were more of like emulating the human brain on making the telecom decision, and then scaling up on the big data platform. Then it came things like smart coverage that would estimate the coverage in every single point of India, on 5 meters resolution, which logically, for somebody that is just coming from telecom, they were saying that's impossible. But if you use the statistics and if you emulate the human brain of the person that is assigned to estimate in every 5 meters, and if you work on the data platform that it's scalable and can crunch a huge amount of data, actually you can do something like that. And on top of that, once that we created this composite smart coverage layer that was the base for decisions, then we realized, okay, so what is the next step? What people will be doing with areas where they want to fix the network? Then we start creating the confidence polygons. Then we say, okay, now when that we have these polygons where we have to fix the network, why we don't give them the names and assign them to people and automate the whole process? I think at some point it came to the levels that Ambani's family could just sit in the room and run the network. The simplification come to the point that there is a list of problems, and the list is maintained automatically, and just somebody has to watch how the things are moving. And the big thing about data scientific approach there was that the whole system won't be able to function maybe after first part of automation. The system design will be blocked because there were no sure direction or decision-making point, because the networks is so complex, so we wouldn't be able to close the loop. But once starting using modeling and parameter selections and some machine learning techniques, we managed to close the loop, and statistically we have outperformed a very good telecom team, which would be extremely expensive to run the network, with the automated platform that was just acting as a human, doing and working on the best effort. And I guess that was that's a part of the Geo success, that somebody who is running the network and it's most responsible is actually enabled to see how the decisions are reflected directly on the network. Because if there is a disconnection between the executives and the network, it won't be. It's very difficult for a company to function. I mean, I must say that until 2008, network maintenance and telecom networks were run by the middle management. So they would actually, we used to sell tools for data, algorithms to the middle management, like radio access network directors. And then after the crisis of 2008, CTOs basically and CEOs got budget, and they were running the network. They wanted to see the network because they had money. So all the tools have changed, so they became visual and geographical. So somebody who is on much higher level, he wants to see the whole country. And then it came the phase. Now it's the phase of when telecom is actually making less money, but it works more and more. So it's a very, very strange phase. It's a very good place for investment. So actually, it's the rich people or big investors that are running the network, and they want to be able to run the network. So data science plays there quite a big role, because the complexity now of replacing the executives and the middle management and forming the view and actionable insights for somebody who is doing investments in the networks and who is making the big decisions. That's where data science fits. So it's not really a data analytics. It's this bridge between network and somebody who is driving the network. And it's like driving, I'll compare it like driving the car. In the beginning, there was million lamps and buttons to press to run the network. Then it was a little bit simplified. And now with all these automations and statistical approach and modeling that is simplifying the network, it actually might end up as having a wheel and the clutch, and one person can run the network. That's the ideal vision for data science. And it's not only, I think, in telecom industry, many industries, scientific data science approach and machine learning will lead to fitting the insights to somebody who actually can make the decision. And we cannot influence who is making the decisions, because that's something that is happening in the world. So I think data scientists are gonna run the world, the world and make decisions. They should always be there to support decision makers, whoever it is at that point. So this is why it's important, very important to listen. If you are doing the automation system for a doctor that is doing the operation, then you actually make something for him. But if you are trying to help one person that has invested a lot of money in the network to make a strategic decision, then you find insights for him. If you are helping the run director to solve some technical problems, then you make it for him. It's very important to understand what people need. And this is where the most disconnection comes, and I think that's the main success story of data science in Geo, that actual people that were making decisions were enabled to make decisions and directly run the network. So I can say what is the perspective and jobs. Maybe it's interesting for you. I think Naka told me that there's a lot of people that are in some mid-career phase, where trying to understand how to not only be a data science, but be a marketable data science, and somebody who can gather really good and interesting projects. My opinion and advice from my experience is that shouldn't play on the data science as a profession, but more like a skill, and should be able to demonstrate the skill, because it's more and more people are learning about artificial intelligence and algorithms and machine learning, and it's becoming like a read and write skill. So making sure that that this is very solid and that this is the best in the industry. So it's very important to be very good in reading and writing, say like in data science, to get a data science job. But actually, you should talk also about what exactly you can do for the specific industry or the specific person. And also I think that entry level into data science, there's a lot of jobs for data scientists nowadays, but entry level, it's very high because of the complexity of job. It's not that somebody is just and also because the business users, they generally can't understand the competence of data scientists. So marketing yourself as a team is very effective. Budgets are high for data science, but the thing is that, is it really going to be a lot of data scientists that are working on a million things, or can they just really solve the problem that I want? Because and then acting as a team, it's a lot of times just because everybody is investing in the area. The limitation is not usually financial. The limitation is just there is no confidence that that person will do what he's saying to do, that he is going to do. So it's still, there is still no clear path. Like if you want to be a surgeon or like doctor, you go to school and you get a job. But here it's still the job is so diverse that acting as a group give more confidence. And there's a lot about teamwork, and building the team takes time. So it's very important to show that you are part of the team, that you like working with the people. It's something that data scientists should create more groups, and not really like a software engineers, not really like a startups, but more like people that can complement each other. And one thing also that is, I believe that you can do most of the work without understanding algorithms. I'm not that kind of people that would say, oh, you have to be a super mathematician, because I've seen that you see the input, you see output, you can train neural networks, you can do whatever. The problem is that's fine as long as you're not building something that have to stand ground and have to stand test, and you also have to convince people. So instead of going and understanding, really spending a lot of time going through the specific cases, my advice is getting the books about advanced mathematics, understanding how this all fits into theory of groups, what is algebra, why do we have matrices, really understanding the way how the multidimensional systems are working from the advanced point of view, because then it's going to build your confidence that whatever comes, you will be able to dig deeper, and you will be able to, and you will be just looking more confident to anybody that is working with you, that you really understand what is happening. Because you can't be expert for every algorithm, but you can have a very good understanding of principles of advanced mathematics, where it is all coming from. And knowing something without knowing where this is coming from, it's possible, but it's a burden. It's not necessary, especially in the days when we have Google. I don't understand why would people memorize specific algorithms, but not understand the principles, how the nature functions, and how these algorithms, and how these matrices, and why these things are happening at all, and what is the generalization of all of this in some mathematical areas. So I would say, I wrote here that, let's say, it's not going to be a privileged job forever. That's my opinion. Maybe it's going to stay for a while, but it's, well, for sure will be always something cool that you did. And even if you move on one day and do something else, and data scientists or algorithm developers or mathematicians or get another name, I think it will be always referred as the very good things that you did in the past. So investing time into education and getting right credentials, it's never thrown away time. Okay, so I can just quickly say something about, again, it's my opinion on data science and big data. I would say big data itself is a marketing thing in some way, as well as very nice approach to simplify the systems with the Hadoop platforms and different distributions where you can handle huge amounts of data as easy as you're handling the small amount of data, and where you can scale up much easier. And there is a lot of products like Spark and similar system that enables you to process data faster and in memory and so on. The thing is that by the statistics, you spend most of the time working on your laptop and working on the mostly on PC platform. And I mean, a lot of time it's a Unix, but so I believe that data scientists should have a very strong laptops, not only because of having a specific environment of a PC and so on. It's also because of dynamic of the work, where you could stop, restart, understand your system, build some kind of relationship with your machine. Because for data scientists, the machines itself, you can be a data scientist and you don't need anybody in your team, and you can still produce a lot of good things, because machines are your employees. This is a big difference, and you need to develop some kind of smoothness of working with the machine. So I like for my employees to be able to even take that laptop home and not work on it, but they can see that if they are processing something on the small scale, they can run and try. You don't always use a big data to prove the concept. Big data is for deployments, and big platforms are for deployments, and there is a cases where you can't make a conclusions without analyzing huge amount of data, but that's usually most of the time because you are not very skilled in isolating the problem, and you always go frontally. So developing some kind of relationship with your hardware, with your machine, understanding it's very important. And my advice is to understand the hardware that you have. It's your tool, and it's your kind of friend, and all the things that you have developed in your environment you will be using, and developing the speed in making conclusions. So I don't believe in data scientists that are all the same, all working on the same platform and all know the same thing. This type of data scientists can be even automated. So this is something that that is very popular nowadays, understanding how to run on the big scale, but it's usually working on the problems that working on the solutions that are looking for a problem. So you know how to do it, but you still don't know what is the problem that you. One more thing I will try to speed up here. It's a open data platform. We are trying to build in Geo a fair platform for the algorithms developers and data scientists to join the company, work on data very quickly, and produce the outputs and be judged by the people that are using the APIs. So the way how we should treat data scientists and algorithms developers, it's more or less as the innovators, creators, artists, so they can invest sometimes and create many different algorithms, and then those that are used, they will be rewarded. Explainable AI. This is something that when you work in the industry, in telecom industry, a lot of times any kind of automation that is using AI and machine learning, it needs to be explainable. If you don't use classification trees directly, you have to involve some post-mortem analysis for the decision or classification, the classificators, where it's going to find why it is making such a decisions. It's not only for curious people to understand. It's also for the documenting the decision, and also for making the any kind of algorithm and model. It needs to develop the trust. It's like a person joining the organization, and it doesn't matter how many good models you can create if you don't make them friendly and people don't build the confidence around that model. Again, it's useless. It won't be utilized. So it's important to think about that, especially in telecom, where there is a lot of telecom engineers that are, and you're dealing with the customer data. It's very important to understand this. So always think about what is the logical explanation for machine doing this. Is it possible to get it or not? And the proper algorithm sharing platform, that's something that we have built in Geo. Okay, so the last slide is one documenting what you're doing. At least from my experience, we always try to write down in one page what did you do. It's really much easier to communicate with your colleagues in data science world with paper and a web page than calling for a meeting every. I mean, some things they just cannot be explained, or they shouldn't be talked about a million times. It's better to have this white paper communication. Maybe people will disagree, but too much talking is actually tiring and leave you the less time to think about the algorithms. I discourage long discussions without. I prefer that we write down things in eloquent way and communicate these things with the people that can make decisions. Of course, it's important to present, and this is fine, but it's tiring explaining machine learning algorithms to everybody. It just leaves the less time to work on them. And always combining your work into some strategy. So that's something that on the long run, whatever you do, think about in which direction you are going. If you are building the system diverging in million directions, after all, the everything that you do should be in some way some kind of product. Maybe not everything will be applicable in one company, but you might have a career through your life, and things have to fall apart together. So must be some kind of development strategy that data scientists have in front of himself. So it's just not accepting sometimes working on the things that are too weird or that don't fit into his capabilities or into his wish. And yes, as I mentioned before, being useful and gentle and kind, and it's very, very important because there is this bit of arrogance that people see in data scientists nowadays, and we definitely have to change that. So, and always keep some kind of magic, because there will be people that will never understand how these statistics work, even though they might be really good in mathematics or whatever. And these people are sometimes the best clients, and they will actually, they're very smart people, but they just don't think like that. And so together with these people, it's much easier to change things. And last thing, it's you should talk about things and be clear about everything, but also having the respect over the complexity of what you are doing. Don't talk about algorithms in the places where it's not a place about getting very deep into things, because things should be simple as much as possible, but they shouldn't be simpler than it's possible. So I've always laughed when somebody's trying to explain the algorithms with a couple of beers, and I said, then you really think that this is not serious science? But that's always happens, that people get excited about things and thinking that this is the life. Algorithms building is a profession, in my view. So that's about it. I think I took more than half an hour. So
thank you. Thank you.
Hope I didn't bore you that so much, but if there is any questions, I will be glad to answer.
Sure. There are some questions. Let's look at some questions. Thank you so much. So there is a question from Siddesh. With so many new technologies coming up, how would data science and cryptocurrency Bitcoin converge?
Okay, I can just make a general comment in that area. I don't know if cryptocurrency generally automatically goes into data science. It's and blockchain technologies. They will definitely converge in the algorithm space. I think we are having a lot of projects in telecom industry that are exploring the cryptocurrencies, and it depends heavily on the regulations and the blockchain technologies. Smart city solutions, for example, are something that is using the machine learning and artificial intelligence quite a lot for understanding your customers. But then on the other side, you want one technology that is taking care of the data. So they will converge in the specific solutions. I think probably in the smart city solutions. That's just on my mind at the moment, that where we are exploring something like this in Indonesia at the moment.
Yeah, thank you. The second one is additional opportunities and challenges that will evolve with 5G deployment, and how data science will be going to help resolve those future challenges.
Okay, so now with the 5G deployment, that I would say it's definitely another technology that is coming in with quite a lot of algorithms in the area. I don't know how much you've been into convex optimization algorithms and this space. There is quite a lot of good stuff done on the Stanford University. If you're interested, you can visit. The data sciences and discoveries in the area of this, like minimum volume embedding algorithms, where you are trying to reconstruct specific signals from the last data, and these all kind of things are driving 5G from the back end. They have a different names, marketing names, 5G, 6G in the future, but mathematics itself, it has its own revolution that are not visible in the industry. So if you really want to do changes in that area, I think data science will be in very fundamental levels of the 5G, and that's where 5G is at the moment. There is a lot of innovation in the area. For the deployment, I believe it will have a similar challenges as a 4G. We will need to find better ways how to detect the areas for deployments, and it's more or less a lot of diagnostic techniques that are used for searching for hotspots and isolating the problems. Root cause analysis will be the same as a 5G. But the main thing at the moment where data science and algorithms are playing the role is in the fundamental algorithms running on the microchips.
Thank you. We have an interesting question here. We are interested in knowing what type of business cases have been solved in the telecom industry. Another important point we would like to know is in which area of telecom, that is EMS, NMS, or OSS, the data science play the big role.
Yes, so as I said, that these areas are very established, like EMS, NMS, OSS. So specifically, they themselves are converging now into solutions. So data science is the factor that is connecting all these products like OSS, EMS, and so on. They were built for the middle management, but networks are not run by the middle management anymore. I mean, this is just the reality nowadays. That all the tools, all the algorithms that are built are trying to find the insights and combine all this information into one platform and serve these insights to smaller group of people that are running the network. Because telecom is the investment business nowadays. The capitalization is the main drive for the telecom development, not really the revenues. So people that have the money are very much interested in the telecom, but people that are running the telecom, they are actually depressed because the prices are going down and there is not much interest in automating anything. It's more of like survival in that area. But there is a huge potential for data science to connect to people that are investing into. So for these people, they need one view of the network. They need to be able to approach their network as their car. And this is where data science has the biggest role.
Sure. So we are running a little short on time. We can take one more question. How much is statistics and algorithms important compared to domain knowledge, especially in telecom? I'm taking this question because many people seem to have kind of similar question. And another question would be, does number portability have an impact on the reliability of data?
Okay, yeah. So I quickly would say that you have to have a mind of the data scientist to actually be a data scientist in the telecom. It's easier and easier to run to be a data scientist in telecom without telecom expertise, because there is more and more people that understand, and also there is more and more or less and less telecom guys in the telecom. Telecom is going through transformation, so I think in the future there will be less need for a domain knowledge in telecom, but it's very strong, especially if you want to be a leader. You need to have a strong telecom. We cannot connect with the business. If you want to be a data scientist, a professional expert in a specific area, that's also possible. Then maybe telecom understanding is not crucial. And the second one is KYC, knowing your customer. Yeah, definitely. Either you are going to have some portability issues in the way that people are easily switching their SIM cards and they are not connected to their numbers, then you will never know your customers, and you will actually, if data is the gold, you will have this gold running from you, because you can have 200 million users. If you don't know who they are, you will not have a gold in your company, and your company will not worth much. And basically, it's not only portability. You can have we are working on the face recognition, authentication algorithms. This is where the data science nowadays is playing a big role. Understanding their customers, finding the way how to authenticate over the internet, how to resolve who the people are, and the big part in that is playing the security. So you really have to understand the security of the data. If you want to be a data scientist and propose the solutions with the face recognition and any kind of cool things where you are collecting the data about your customers, people get scared. So you have to have a good knowledge in the security solutions. Or if you don't know, you need to have a team or your friends or somebody who can help you in that. Otherwise, you will not get assignment. The people are just scared, letting everybody collect everything about. And that's why we believe we trust some companies, and there are companies that we don't trust. So companies that are smarter and have a better approach in even in branding itself as a data scientist company are more trustable than companies that are having a approach where let's do everything without actually having a good plan and good system.
Okay, thank you so much. Yes, Ms. Nikola, thank you so much. It was a very realistic presentation from the point of view of a user. Thank you so much. Could I may I ask you to pick a winner for this webinar? So the best question gets a book as a gift from us. So okay, the questions, if you could pick a winner, it would be great.
Okay, so a winner of the people among the people that have asked the questions. Yeah? Okay,
yes.
So let's say that it is a slide 5. So 5th person would be sent to.
Okay.
Right?
You mean the second question, or Senthil? Does number portability have an impact on the reliability of data?
Yes.
Okay, perfect. Congrats, Senthil. You're the winner. So this is the book that would be getting, Python Data Science Essentials by Alberto and Luca Massaro. So I hope you enjoyed this presentation. It was a very realistic one. Thank you, Mr. Nikola. Very happy connecting with you.
Thank you.
We will be sharing the presentation and the recording with all the attendees. We hope to have more sessions from you.
Okay.
So
thank
I
you.
think for tonight, everybody sleep well. Good night. Thanks.
Good night.
Yeah.
Good night. Thank you.
Good night. Bye.